Colloids. Colloid is a mixture in which the particles are larger. So you've got a dispersed substance in a dispersing medium. So this is not a solution, it's a dispersion. It's also called a colloidal dispersion, sometimes also called a suspension. So the particles are small enough to stay suspended, but they are larger than typical solute molecules. So colloid particles are typically around 1 nanometer to 1,000 nanometers in diameter, which is significantly larger than most ions and molecules that form solutions. If we look at the molecules in a colloidal suspension under a microscope, they are large enough that they can actually be seen. And we observe a jittery motion. So we see this, and it's just like jiggling all over the place. It's called Brownian motion, and it's caused by collisions of those molecules with molecules in the liquid. So I have a YouTube video. What happened? This one's really short. So this is that Brownian motion. They look like they're alive, right? And at first they thought, oh, these must be cells, little organisms, but they're not. That was short, huh? Yeah. But that's Brownian motion. So when you add soap to water, the soap dissolves in the water. When you get enough soap in the water, the soap is going to aggregate and form micelles. And I drew a picture of this for you earlier. It forms these micelles with the long nonpolar tails in the center and the polar heads on the outside. The polar heads interact with the water just fine. The nonpolar tails don't like the water doesn't like them. But soap can wash away greases and oils because these nonpolar tails like the grease and the oil, and so they get encapsulated in the soap and then they can be washed away. These little micelles are much larger than water molecules, but they remain stable in the water because they have repulsions between them. So there are electrostatic repulsions between the micelles that keep them suspended in the water. Those particles are large enough that they can scatter light. So if we look at this picture over here, this is soap in water. You add enough soap to the water, it doesn't matter if the soap is clear or not, it's going to get cloudy looking because the micelles that form are large enough to scatter light. And we observe, I'm just going to go ahead in this one. We observe the Tyndall Effect. So if we shine a bright light through these two beakers of clear liquids, one of them, we can see the beam of light in the liquid, and this other one we can't. This is a colloid, this is a solution. The particles in a solution are too small to scatter light. The particles in the colloidal suspension are large enough that they can scatter light. And so shining a beam of light on something, you can test whether it's a colloid or a solution. Same thing happens in the air. You see sunbeams coming through the window, and you're like, ooh, I can see the sunbeam. Why can you see it? Why does it show up as this shaft of light? Because there's particles in the air, right? In a house, it's usually dust. So there's some dust in the air, and the dust particles are large enough to scatter the light. If the air had no particles in it, it wouldn't scatter the light, and you would not see those sunbeams shining in. So there are many different types of colloidal dispersions. These are some that we might encounter in everyday life. An aerosol is the dispersing substance, which is like the solute, is going to be a liquid. It's dispersed in a gas. An example of that is fog. A solid aerosol has solid particles dispersed in a gas. Smoke is an example of this. A foam is gas dispersed in a liquid, so whipped cream. Anybody have pumpkin pie with whipped cream for Thanksgiving? You ate a colloidal dispersion. An emulsion is a liquid dispersed in a liquid. So milk. If you have raw milk just straight from the cow, not treated at all, and you let it sit, the cream rises to the top. The fat rises to the top because fat isn't soluble in water. And then they skim the fat off and make butter out of it, and the rest of it's called skim milk because they skimmed off the fat. You can buy whole milk at the grocery store. You buy whole milk at 7-Eleven. It's got fat in it. It's all of the milk. They didn't skim anything off. Why doesn't it separate? Because they homogenized it. It has undergone a process to make the fat globules stay suspended in the water, so it doesn't separate out. And then you can also have solid emulsions. Here you have a liquid suspended in a solid. So an opal is a silica glass that has water suspended in it, and that's what gives it its pearlescent appearance.